object-oriented programming. Class is a blueprint or a template for creating objects. Consider the class cat. For some of you don't know what a cat looks like. They often have 4 legs, 2 eyes, and optional fur and tail. To make it easy, let's define some common attributes of cats. Cats may vary in fur colors, eye colors, genders, and age. Those are called instant variables of the class cats because each cat instant will have those attributes. So after defining the class cat, we can create objects from the template. We can create an instance that has black fur, yellow eyes. This is a male cat and he's 3 years old. From the template, we can also create a different cat with yellow fur, black eyes, and she's 2 years old. Similarly, we can easily construct another baby cat with blue eyes, white coat, and she's 3 months old. The cat class can also define not only attributes or properties, but also behaviors like running, climbing, sleeping, etc. And all of the objects will have those behaviors. When discussing about classes, one of the most important topics would be initialization or constructors. Every class has a constructor or init method. Each time an instance or an object is being created, at least one constructor will be ultimately invoked. In some languages like Java, it has the same name with us, while Objective-C or Python has init methods. Constructor or init gives you a chance to set useful values to instant variables. Think of constructors as a time before you're born. Your parents will initialize you with their traits like hair color, eye color, skin color, etc. And you are born initially with those traits. However, you may be able to change your attributes later after becoming an instant. For example, you may be able to change your hair color from blonde to black when you reach 15 years old. In object-oriented programming, inheritance allows new classes to take on existing classes. A class inherits from another class is called a subclass. The class that other inherits from is called superclass. The relationships of classes through inheritance give rise to hierarchy. This allows classes to share common traits and behaviors from other classes. For instance, we can define the class animal that has very generic traits like number of legs, number of eyes, tail or no tail, and some generic behavior like eating or moving. Then we can have more specific classes that inherits from the class animal, such as mammal, bird, and arthropod. They share the same instant variables like number of legs, number of eyes, but they may have more attributes that are specific to their classes. Then the class mammal can have more subclasses of its own, like human or deer. Human and deer may share similar traits, but the class human can define methods that deer doesn't have, like speaking. In some languages, there are notions of private, protected, and public access modifiers. This allows encapsulation in object-oriented programming, meaning information hiding. Those modifiers let the compiler know whether a variable or a method is accessible to other classes. Let's talk about private first. Think of anything in your house as private, and your neighbors won't have access to anything in your house without your permission. If they want to borrow your money, they will have to call you first and ask for it. Otherwise, they violate the law, and it's really bad. Now, your house is private to your neighbors, but not to your kids. They have access to those stuff that you specify as protected. On the other hand, anything that you specify as public will be accessible to everyone, like everything outside your house. You might want to ask when you should use protected instead of private. Some languages don't even have such notion. They are either public or private, or even optional, like Python. In most languages, private instances or methods are only accessible within the class that defines them. For example, the class parents can have the property money private, and even though the class children inherits from the class parents, children interested won't be able to access to the property money. In some languages like C++ and Java, protected instances, however, will let the children access to the parents' protected properties, while other classes won't be able to. Think of this as anything inside the house like the sofa, the TV. It is recommended to use private by default to reduce coupling. The final important pillar in object-oriented programming is polymorphism. So polymorphism is the ability to present the same interface during underlying form. For example, parent class can have a method called speak implemented, but the children class can override that implementation with their own implementation. If a subclass doesn't have its own implementation of speak, then the parent speak method will be called by default.